Hello and welcome, everybody. Welcome back to the VMware Networking and Security channel on Twitch, or better known as VMware NetSec. This is the place where we talk about networking, security, VMC and AWS. We talk about HCX. We talk about ALB. We talk about automation. We go all the way around in the world, talking about everything that you can do with all of our different product lines and how it can really make sense in your business. Now, today, I have a very special guest. I have one of my coworkers that I work with, and today is going to be a focus on a networking side of it. So we're going to talk about networking, basically NSX 101 of how networking works in it. We're going to start talking a little bit into edges. We may get into routing. We don't know where we're going to go. We're going to have a lot of fun here, and it's going to be a wide open discussion. He's got a light board that's there that if you saw in the very first episode what we did with Chris McCain, there's going to be a lot of fun drawing, a lot of fun back-to-back conversation going off. We're going to show a little bit of the NSX manager that I have in my lab and dive even deeper. And if you have any questions, feel free to ask. Feel free to put them in the chat. More than happy to go into it. And if we don't have the answer for you today, remember, we'll get back to you. We'll be able to contact you, and we'll get you that answer at the end of the day. So now, without further ado, let me introduce my coworker, Paul Mancuso. So, Paul, how you doing?
How you doing there, Andrew? It's a great, glorious, beautiful day down here in South Florida. Hope everyone else is experiencing as fine a weather as I happen to have today. It's not pouring rain, even though summertime is here. We tend to get rain just about every day for at least a brief portion of it.
Yeah, you're lucky. So we're in the middle of a heat spell right now here in Michigan. I finally had to cave. It's like 88 degrees outside. I finally had to turn on my air conditioning, and I'm hurt that I had to do that because I tried to hold out, but you know what? I did the best I could. So I like to start off these things, Paul, by asking the question of, so where did you come from? I mean, you're here at VMware, and you've been here for a while, just like Chris McCain has, and you have a long history of what you've been doing. So please tell us where you came from and what you did.
I was born in a small town in St. Louis. No. I began my IT career teaching DOS, of all things. Back in the 80s, I had customers that didn't know how to set up the DOS environment. So naturally just started helping them out because I was crafting computers and systems out of the garage. Unfortunately, didn't end up being the great wealth empire like Dell did from his early beginnings. But nevertheless, it did build from there. I got into networking just because I was sitting in a company a training, and they sat there and said, you should go take this Novell stuff back in the old early 1990s. So we're talking 91, 92. So I learned that Novell, which is obviously doing wonders for my career today. Right. And from there, in that class, that first Novell class, I started helping everybody else in the course because the teacher was constantly going in and out of the room for whatever reason. And she noticed this and she says, you make a good instructor. And then from there, I started doing instruction along with consulting. So kind of pairing the two together throughout my contracting career for the better part of most of my adult life, starting from the early 20s all the way, well, to my age today. We'll just let it go at that. And then when VMware came on the scene in the early 2000s, Chris McCain actually got me involved in that because both of he and I were in a business together already doing boot camps for Microsoft NT and Microsoft Windows 2000, et cetera. And I was doing the Cisco portions of our turnkey solution for offering boot camps and things of that nature. And he got me involved in VMware. So I added VMware onto my credentialed list of being able to teach as well as deploy. And then from there, I'd already had a huge wealth of networking knowledge from Cisco from the 90s. I was working with Cisco for advanced services and contracting through them. So I was a red badge Cisco contractor for about 15 years. And then right around 2015, I had already done my VCDX in one of Chris McCain's first Ninja courses. In fact, it was the initial Ninja course in 2013. Got my VCDX. I was teaching the Cisco advanced courses for the CCIE and the CCNP and the CCSP. That's the security track that they had at the time. So I naturally just came to work at VMware because they liked the fact that I had a broad spectrum of capability so that I could bring it into the NSBU and offer that as a means of architecting and designing solutions for the customers there that they have. And then from there, I've essentially stopped teaching Cisco courseware because they kind of felt that was a bad idea still working for, or started work when I started working for VMware. So from there, I essentially talk a lot with public discussions dealing with just how do we architect and designed network and security solutions, although today will be a prominence of only the networking aspects. We'll dabble in the security just so you understand how it works inherently with the networking part. But essentially, it's all about networking today. So there you go.
Well, that's wonderful. So, as you know, everyone in the audience can tell, there's a wealth of knowledge here when it comes to networking, security, a lot of background there. We both have a long Cisco history, so we talked a lot about security and automation, but I think this is the other exciting thing about NSX is like we're going to really get into the networking portion of it, which I think a lot of people sometimes forget because we focus a lot, and for good reason, because the DFW and everything that we have there, the IDS, IPS, ATP, we have a fantastic set of features there, but we really need to show some of the coolness of the networking side. So let's dive into it. So you and I coming from this history, CCIE and things like that, and all the different training that we have gone through in all these different years, we learned about routing and switching and, layer 3 SVIs and all these different things and the complexity that is involved with designing a network. How is that different in NSX?
Well, with NSX, and that's great, with NSX, we have to look at where we reside within the environment. Now, you did this with Chris. Chris even mentioned the fact that we have that advantage, that advantage location of being in the hypervisor of the infrastructure itself, where a predominance of the workloads are operated within. In other words, almost all customers today, I wouldn't say without exception, but almost all customers today probably are somewhere in the 80-20 to 95-99-1 mix, meaning the ratio of virtual to physical is in the hypervisor, and vSphere happens to be the king in that area as well. So we tend to be the predominant locality where your workflows are being interacted upon for network and secure servicing. So when NSX came on the scene, as VMware bought Nicira, transitioned it to NSX, and then essentially vSphereized it, if you will, because Nicira, the network, the NCP servicing at that time didn't actually even have a vSphere component. And then it was instilled within it, and then the very first flavor of it was NSX for vSphere. And it's good to know a little bit of the history so that when you are learning NSX, you're learning and seeing that if someone's mentioning NSX and it sounds a little odd, make sure that they're talking about the flavor of NSX that is today. And today it's NSXT. NSXT was I would say, technically the third major iteration, because the original one was we took NCP, added a little vSphere to it, and we called it NSX for multi-hypervisor. And then the second one, which is the biggest release we had at that time, which was NSX for vSphere. All right, and that was, of course, a version that relied explicitly on NSX, vSphere, because you had a plugin and how to operationalize NSX through vSphere. That was the only way to manage it. And NSXT brought along a separate dashboard and an advanced depth of differences in how NSX can operate its network and security servicing, although from a 10,000 foot view, it looked almost the same. Virtualize the network, inherent security flows, and wrap that over a physical environment. T essentially is the same, except inside of its coded services, it is entirely a different animal in that regard. Its networking is far more capable of what we were allowed to do with the way NSX or vSphere was coded originally. And T has an extensive capability where we're continually adding enhancements to its advanced networking service capability, as well as, of course, the security that you've already gone through, or at least a portion thereof, with Chris, right? And then I think you even had, if I'm not mistaken, this is the third one of your thing, right? Didn't you have an automation one or something like that? Or
yes, we did.
Okay, yeah, and the automation one showed you the value that the way it is now designed, that single API model allows us to run the entire stack through a single API call, networking included. So obviously it's a little marketing gimmicky there, but it's actually reality. And that's something that should be noted, because yes, marketing says one thing and it makes it sound wondrous and glorious, and there's obviously pros and cons to it. But the one aspect of that particular statement is that single API model. We hear that all the time from the physical fabric vendors out there, but what they're only giving you is an API to manage the flow of connectivity from a physical, a down-up perspective. Now, we're going to wrap this around, and we'll in my later drawings, and we'll show this actually as vSphere from the ground up, because normally people see their diagrams, they have vSphere down here, the physical up here, and then the internet connectivity up into the clouds. I draw it this way initially just because I'm going to draw a bunch of things up top of it, so it makes it a little easier just to visualize it. But technically, vSphere is the southern, and NSX is the southern. We're the stub network, if you will, and we're going to get into more of what that means. So how would you like to begin that movement? Where would you like to go with this first?
Well, let's start off with, as a network administrator or an engineer, architect, wherever you're working in this environment, the process was, I would have to sit there, and if I want to create, let's say, a new layer 3 SVI, and I want to bring that into vSphere, I gotta carve out an address space within my area. I have to create SVIs within my switches. I have to trunk those things down. I have to figure out how the routing is going to go, how the redistribution. How is that different in NSX? Like, what are we doing that I had to touch all these physical components last time? What's different in NSX, and how is it easier?
Right. The older version, as you just said, to me, technically, it's the legacy model, because it is the physical infrastructure monolithic model where, craft a VLAN down here, and then you'd have to create the corresponding distributed virtual port group in vSphere, and then you had to have a little symmetry between them, and you can either use an unsupported proprietary extension to manage that in some manner, or you could simply run automation routines from vSphere as well as from the physical fabric in order to make certain that they negotiate appropriately. And then you had to also craft your gateway values, and then you had to make certain that was aligned across the fabric. Now, fabric management tools today, to be fair, can provide an automation of a lot of that too. So there is a single one button push to do that in the physical fabric. So I think I don't want to makes that sound as if it's still this tedious process of going switch by switch. That is not the case today. Arista makes a fine tool that does something of a similar nature to manage the fabric. Cisco has a couple of different tools, Nexus Dashboard, that can provide NXOS and a little ACI integration as well, or you can do it with just ACI with ACI's services. And then, of course, Dell switching, I have no clue. Okay, all right. But I'm certain that they have a fabric tool that provides a means of doing it across the board. Juniper has its own. But the idea being is that even though we say automation is a one-button push, that's not so much the thing, because we talk about the setup and how simple it can be done in either physical or virtual in the way we're going to present it today. But again, remember, and keep this in mind throughout the session and any of the other sessions, because I'm hoping to come back and we'll delve deeper into many of the things that we won't get into today. But keep the fact that no matter how simple it may appear, pushing a button and automating your fabric, think about, you have to go back and troubleshoot that automation, right? And often I think that is missed until the uh-oh time occurs. Everybody knows that I got to do it, but they forget that they actually have to go do it, and their mean time to repair operations begin to get extended quite drastically due to the complexity of trying to incorporate all of that. And I'm going to refer to it as intelligent, secure network flow, where we can do that in an inherent fashion in the hypervisor, and we can do it correlated in any manner you so desire, whether it's separate administrative silos, correlated silos working together in some RBAC fashion through a tenant-oriented system, across one site, multi-site that we'll get a little bit to later on in the session. But nevertheless, all of that would have to be siloed if you do it the legacy model. And this is where I think customers sort of miss the boat a little bit and think, I'll just do it in the same manner and I'll be able to get things done just as quickly. Well, again, I think we're going to show where there's some pros and cons with the way we do it. And I'll offer a few cons here and there where I think that you might want to catches, you might want to be aware of. But at the same point, we're doing it the way most customers have wanted to do for years. How do I get networking and security and workflow correlation all done in a single location? And that's what we can do with NSX. All right.
Yeah, I agree. And I think that there's, this whole aspect of the distributed fabric and what you can do here. look, we're here on this pod, this live stream to not discredit that there are other things that you can do on the underlay. You clearly stated that there are a lot of things that you can do when it comes to Nexus dashboard. We're not discounting that's there, but we feel that the way that we do it within NSX and our networking aspect is really unique, and it allows you to be able to integrate all of the networking security, IDS, IPS, ATP, everything within a singular fabric that is distributed out, which is, in our opinion, the right way to do it, and it's the most intuitive way to do it. Would you agree, Paul?
Well, that's just it. I'm drawing out right now on the screen as we begin, and we'll get into it a little deeper so that we can focus a little tighter on this. But I'm drawing out the fact that with NSX, and I think these are the key elements of this discussion, is that we can incorporate distributed switching and distributed routing right there in the hypervisor, so that when you have two or more workloads on the same hypervisor, all communicating across a single broadcast segment, in other words, what normally would be considered a VLAN, we'll refer to it as a logical segment, all right, inside of our Geneve tunneled traffic, all right, in our network virtualized world, all the different phrases, in our overlay, however you wish to hear it and make it sense to yourself, we can present that communication, routed communication, inside of the hypervisor, so that all you have to do is just simply draw lines, if you will, through the API, and you're done. And the communication occurs across a vast area that we'll call our transport zone, that we'll discuss in a little bit as well, which gives you the scope of where those segments, distributed routing and switching, and the firewall servicing that you had in your previous segment is being administered through, so that I could have a cluster or an entire data center of clusters, or even multiple sites of clusters, all managed through that single scope of configuration, without having to do a very tedious manner of trying to touch a lot of elements in order to make that happen. So let's get to this a little deeper, right?
Yeah, I want to do this. So let's get in a little deeper. Let's start off actually at the very beginning. So we were talking about a broadcast domain or a VLAN or a segment. Let's talk about a segment. What does it do? How does it allow VMs to communicate with each other? Let's say we're in a CLOS architecture and we need to have this segment go between different layer 3 segments that we have in our physical network. How is that working? How is it doing it?
Okay, in the physical fabric, you would normally, like I said, you would craft all of these different VLANs, and then you would have to touch either all the switches in the old legacy style, or you would have a fabric tool that would simply instantiate that VLAN value. And then you'd have to correspondingly create a distributed virtual port group so that the vSphere environment, the distributed switch vSphere environment, would have that VLAN value attached to the same physical uplinks into the physical switch where that VLAN has been trunked, right? Where that VLAN is trunked from the physical fabric itself. But with NSX, what we do is this, and this is the simplicity factor. We craft a single abstracted logical interaction with the physical environment. And we were going to refer to this as our tunneling endpoint, our TEP, all right? And that's a single VLAN. So it is a VLAN. We're going to essentially utilize what is required of Ethernet communication in order to make our transport world operate, but it's a single abstraction. Now that's important, because at this point now, I don't do anything in the physical fabric in order for me to now craft a series of logical systems or logical broadcast domains inside of the hypervisor. So I can draw all of these logical segments that are scoped across one or more of my clusters. Remember I said this, so that if I got 6, I got 10, 64 host cluster, all of these clusters can have that logical segment by a single call to state that it exists. And we'll talk a minute more, because that's going to get into our distributed routing. It's going to be distributedly switched with a distributed gateway value so that we can route it off of any host within that fabric. One site or more sites. The multi-site stuff is to be done in a little bit. So we'll stick with just 2 segments, keep it simple, right? So pretend that these would be 2 VLAN segments, right? Well, they would then be DV port grouped. There'd be 2 DV port groups on your vSphere host. So if you're picturing this in vSphere, you'd see 2 DV port groups, and they'd have that VLAN X value in it. to note what that VLAN corresponded to its physical interaction. Inside of now, it's actually going to be a part of NSX distributed virtual port group managed abstractions in vSphere, so that when you tell NSX to make a logical segment, it crafts the exact same looking DV port groups to the vCenter admin. So they're not seeing anything distinctly different of any sort. And transparently, there's an understanding now. It used to be opaque. Now it's a more of a transparent nature because we're using the native distributed virtual switch servicing of the vSphere host. And we're just giving it the same logical broadcast connectivity, so that when you place a virtual machine on this segment, so I place a virtual machine on this segment, and a virtual machine on this segment, whether it's on the same host or a different host, they're on the same logical broadcast domain. And this can be on a host in rack 1 to a host over in rack X within that data center. And again, this could be cross-site, but at the moment we'll stick with a single site in this discussion. So if I wish to then have it connect and interact with a host on a workload on a different host of a different logical segment, I now have two different logical segments. In the old world, this would be inter-VLAN routing.
Correct.
Right? The virtual workloads would have their default gateway, which would be some physical or some, which we would often refer to today now, a switched virtual interface, right? So you have a VLAN that chunks into the physical switch, and the innards of that physical switch has a logical abstraction called a switch virtual interface, which is an IP address that allows communication off any port that's got that trunked VLAN. Well, now, instead of having to hop back and forth, so that this three-tiered network would have to go from virtual to physical to virtual to physical to virtual to physical, it simply just hops within the virtual infrastructure with maybe a relay through the physical fabric through this single tunneled endpoint. So that we're essentially going to allow from any communication to any IP addressed workload, all done through a single virtual fabric abstraction for interconnectivity and intersecting with the physical fabric, so that the physical fabric just sees all of these segments managed through that single VLAN abstraction. So it's a tunneled connection. So if you were to draw the packet, you'd see the VLAN value, and then of course you'd see our Geneve encapsulation, which is essentially VXLAN-like. It just has some enhancements that we're not going to go into here because I don't think we want to talk about that today, but it has enhancements. This is why we chose Geneve versus VXLAN. And it has enhancements to the way you can actually impose additional service capability in the Geneve tunnel that doesn't require to go through a massive undertaking of reconstructing an entirely new standard, if you will. It's actually meant to be extended. So that's why we chose Geneve over VXLAN. All right, so you can.
I want to highlight one thing that I think is really important for the viewing audience that might not be as familiar with this. There's something very powerful that you just said there. The fact that we used to have tromboning effect, if you will, where you would have to go out from one segment that you have on the orange there, going out to the physical area to go to the SVI or the gateway, to then be switched off through the ASIC and then brought back over to the green segment. We're not doing that in NSX. We're doing that right in the hypervisor. That's a powerful thing right there.
That is correct. And what you just noted too is that we have essentially a distributed routing component. Okay. Now in NSXV, we just called it a DR. In NSXT, which by the way, the T kind of goes away in the newest iteration of NSX. For those not familiar with the fact that NSXT has had multiple version trains, starting with 1.0 all the way through now its current version of 4X. And in 4X, they dropped the T because we've essentially sunsetted NSX Data Center for vSphere, or NSXV for short. And therefore, it's just now NSX. But for the purpose of this discussion, we'll stick with the T moniker on it just so that we understand that we are referring to the latest version of it, if you will. So anyway, this is now called our T1 because it's our tiered distributed router within the environment. And this intersects on a distributed fashion every workload on every host. So, and we'll get to a little more detail on how that operates. And then this communicates to essentially the tier 0. All right. The tier 0 technically is also distributed. That's kind of the confusing nature of it, but it only has physical interaction wherever we're going to discuss a little bit later on something called the SR function. So there's a service router function that we can assign to our edge nodes that provides a specific service on that element, on that edge service, so that it provides, it could be load balancing, it could be NAT. All right, now load balancing is something of a legacy aspect because the NSX load balancer that's there today, so I don't want to confuse people because people have already probably heard about our AVI load balancer, now called the advanced load balancer because we're creative in naming. Okay, and but we still have the load balancer. It's still there, deprecated in 4X. If I'm just referring to the fact that because it is still there. All right, NAT, of course, I've already mentioned. And of course, we also can do physical to virtual connectivity. All of those are service router functions. We refer to them as the SR. Where does that occur? Because we do have to pinpoint where that occurs. So even though these elements are technically distributed, and I'll just kind of draw a little dot throughout the racks of the ESXi host of that transport service, so that these hosts understand how to map the MAC values to a tunneling endpoint so that we can provide control plane understanding of the data plane interaction. Now, I know that's kind of already gone off the rails for some folks because they're not familiar maybe with the manager plane, the control plane, and the data plane, but that's essentially the three-tiered element of any network fabric managed environment. Those are all the three. The management is how you construct, the control plane is how it learns and knows where things are occurring, and the data plane is how it actually interacts in a high-speed performant manner. All right, that's those three, and I would say fairly broad, general, not so great specificity of a definition of each of the three, if you will. All right.
Let's also highlight the fact that with the T1s and T0s that you have there, when we're creating these constructs, it's not like the network administrators having or whoever's administrating NSX has to go in there and create that plumbing. That's automatically done. It's automatically created. When you start creating these different tier 1s and tier 0s, it's automatically interconnecting them. It's automatically doing the IP addressing. There's no logic that has to be done. Whereas beforehand, if we wanted to create segments between segments of routers or SVIs or things, we had to think about actually interconnecting these things with layer 3 segments. We had to think about routing and routing protocol distribution and all that. We don't have to do that here, right, Paul?
That's correct. When you set up your NSX environment, your deployment goes like this. If you're obviously going to do the network virtualization, because remember, if you're not doing network virtualization, you're just going to do NSX with security, well, then there's essentially two different bifurcated ways of doing your NSX setup. But you would establish your NSX management environment, right? Now, technically, it's actually 3 of these. So, you know, we'll actually draw them out here for the moment. Normally, I just draw 1. There's a reason we're going to draw all 3 for the moment, just so that you're aware that there's technically 3 of these, okay? That's our cluster. Now, you don't have to. In a lab, you could just use 1. Production, you should use a cluster for availability because we have to have 2 of the 3. In other words, a majority node ideal. So 2 of the 3 must persist in order for NSX to operate in a read-write fashion. Otherwise, if there's just 1 or none, obviously there's no NSX management. Okay, so I want to make certain that we understand that. 1 just allows you a simpler way of incorporating a recovery, but we're not going to get to recovery probably today because that's just too broad a topic at the moment. We'll probably do recovery as a single session. I think that'd be a great idea, Andrew.
I think so.
All right, so anyway, we got a single site, cluster of NSX management, and that's our manager plane. We instill the control plane understanding inside the vCenter's environment. So the distributed switch understanding of how it's correlating the conduct of communication will then incorporate that understanding inside of the tunneling endpoint so that the control plane of NSX Manager dictates to these tunneled endpoints, which are on each host. So each host will have this thing called a TEP. That's the tunneling endpoint of your overlay connectivity, the exact same thing you would do in a physical fabrics TEP. So there's no distinction in that regard, and you map the MAC addresses to that TEP, so that it's essentially a MAC value to a tunneling endpoint, which essentially tells NSX and, if you will, vCenter at least, where that virtual machine resides within the network virtualized fabric. So when communication has to go from one workload to the other workload, it has to know and discover where that virtual machine is mapped to a TEP, so it knows where the TEPs to send communication between two hosts. Now, if the TEP understands that both MACs are on the same TEP, the host knows that the two virtual workloads are existing on the same host and therefore can just switch it on the same host. And the beauty there is you get an opportunistic switching factor of well over 100 gigs, because on the same host, you get whatever the backplane of that host can process communication. There's no physical fabric that's offering this downgrade to the 10, 25, 40, or 100 gig speeds of the physical fabric. We can just do whatever the backplane of a host can do. So if your competing host is some of the better hosts starting from just 4 years ago to today, you're getting over 100 gigs of performance on the same host between two workloads. That's an opportunistic value. Now, obviously, you can decide whether or not you wish to have that because there's HA concerns and things of that nature. But nevertheless, it's an opportunistic value that you can count on when you're communicating. And you can do that switched or routed on the same host.
So that sounds like the magic there. So you were talking about if we were going to go down to that very little purple line that you have going to the switch fabric, those TEPs and the ability of you to be able to basically assign that VLAN that goes up into your host, you can create 1,000 segments, and you're not trunking 1,000 VLANs down into your physical switch. That is still just a singular one that's then taking care of the tunneling using Geneve to be able to then bring that to your distributed fabric. And now those things, those segments, and the DR functionality of the routing can live everywhere in every single host. And if the host has, let's say, like you said, 2 VMs that are living on that same host, it's not leaving that to that physical fabric. It's all happening within the hypervisor itself.
Right. So the two hosts could be on the same broadcast domain, or they can be on a different broadcast domain in order to opportunistically get that higher performance of connectivity. And by the way, the connectivity numbers I'm offering, we refer to them as near line rate when we have to move a packet through the physical fabric to another tunneling endpoint, de-encapsulate it, and then place it on the logical segment, which, by the way, we'll go through in a little bit here. We refer to that as near line rate, meaning that if you have 10 gigs, we get 9.x, all right, somewhere around 9.2 to 9.6 with stateful firewalling. That is key, all right? Or 25 gigs, we get somewhere around 22 or so. Now, you have to incorporate offloads in order to get those performance numbers on the 10 and the 25 gig speeds. So I want to make certain that people recognize that there are offloads. The VMware compatibility guide will give you good understanding of where we recommend certain types of NICs on your hosts. But if you look, this isn't like the old days where, you had to buy a vSphere host that was perfected to run in vSphere. Essentially, most of the broader based NICs that are out and available today will probably have the offload capability. So it's not usually a concern, but you should definitely check to make certain that we do support that NIC for the offload capability.
Yeah, I think that's actually a very important point, and we don't really talk about that very much, is the performance capabilities of NSX. A lot of people I have heard in the industry, even when I was starting to use this in the very beginning, we had a lot of application owners that were very much doubtful of, it's going to be virtualized, it's in software, it can't be as quick as my physical switch, or it's going to slow down my application, it's going to make it add latency, and then it's going to go slower. But that's just not true, Paul.
That's correct. And Samuel Komu, who I pretty much think perennially, or is it annually? Annually, I guess. Perennial sounds like a flower. Okay, annually does a VMworld to now called VMware Explorer session that discusses performance. I don't know if there's one offered this year, so if not, look in the last 2 years that he did one. But he does a session and he does demos demoing the use of the offloads in order to garner that performance enhancement. And then also shows if you did have 2 VMs, whether they're on the same segment or different routed segments, that huge high performance connectivity. And he does it live. So he throws caution to the wind and he does the whole session live on the demo, and it's pretty cool. So it usually gets customers or people in the audience just kind of going, wow, I never realized, as you just said, virtualized can get the performance that you can get from physical and firewalled. I want to make sure I keep saying that, because we're not just talking about giving you a glided path for communication. We're giving you a glided, secure path for communication. That's a very key value there.
I think, and I want to relate this to the customer ask and how this makes a difference. So we talked about how, you know, the TEP, the magical VLAN, if you will, we're going to call it for now, just to have some fun with it. But, you know, back when I was working, and I know a lot of network administrators that are out there, when you wanted to add in additional VLANs, you wanted to add in trunking, you want to do that. Look, that involved change controls, that involved peer reviews, that involved having to do it potentially on a weekend or at night or at 2 in the morning or whatever. And you had to make sure that you didn't, you know, accidentally have, let's say, a junior engineer that was doing that, you know, fat finger something or make an error when they're trunking it up to the hypervisor and working with everything. You're not dealing with any of that in this situation. That is a business, that is a game changer for a lot of people, because now you have the assurance that you can create these segments, or what used to be in the mindset of networking of VLANs and SVIs. You're doing that in real time. You're doing it in seconds with an API call or even with a click in the GUI.
Correct. And I'm just drawing out here what would be required in the initial setup. So we started talking about it. We kind of got off on a little tangent there. So let's go back to it. We deploy a cluster of NSX host. We want network virtualization. So you're going to start specifying which hosts are going to be part of the transport environment. So you have to craft a series of abstractions to make that occur. All right, inside of NSX. The guides will work you through it all in how to do so. There's even a bit of wizardry and simplicity in how that's actually scoped out, so that you're not having to do everything individual items and having to craft individual attribute values on each thing. So it'll actually draw you right through it all, and our documentation tells you explicitly how that's done, as well as the wizards themselves that will process it and push you through it. And then you also have to go in and do the transport nodes, or the edge transport nodes for the edge itself. Now, this is where we start getting into, I would have to say, remember the cons, there's some pros and cons. The pros, we've already gone through quite a handful of them. The simplicity of making it all occur once you have an environment that exists. One of the cons is getting people to operate or understand the operationalization of the edge routing. And when you go to set this up, there's a little bit of a what the heck kind of factor initially when people look at it. And then when you start to draw it all out, like I just did, and make certain that you understand it, so just get a whiteboard, map it out in your little world, and figure out exactly what you wish to have architected in the solution that you are trying to provide for your use case issues, you'll start to recognize that it's actually pretty simple. You're going to create an edge node that's going to start with the T0, because you got to have that first. That's your edge interaction that will bring encapsulated traffic through an edge node, an actual virtual or bare metal form factor, because you can do bare metal, but we'll assume edge is virtual for right now, into your virtual machine. And it will translate it from the Geneva overlay and remove the wrapper of the tunnel back to a VLAN-backed connection through either a static OSPF or BGP routed connection into the physical routed services of your underlying fabric. These are all.
I want to hammer in on one thing there for the viewing audience. So just to make that clear, think of that as your on-ramp or your off-ramp into the NSX fabric, the virtualized networking, the everything that we have going on in there. Your T0 is going to have the physical connections that are going to go off from your edges into it. We're going to get a little bit more in-depth on edges, and we're actually going to also get a little bit more in-depth on, you said a key term there, transport nodes and transport zones. We're going to go back to that in a second, but let's continue on with the discussion of the edge and getting into your switch fabric.
Correct. So what is key understanding here is that if you're going from the physical and to interact with the virtual, so in other words, there's a request coming from the internet or within the data center itself, because there's some physical systems that are still communicating, or virtual workloads that are still on a legacy DD VLAN backed world in your vSphere environment, or it's your own interaction of your enterprise coming in and out of the enterprise environment and back into the physical fabric of the data center. So there's this VLAN-backed communication that's coming in across a routed connection into the T0. So what draws it there? Well, all of these segments have an IP domain space. So all of them will have some IP domain space. We're just going to keep this really simple speak for right now, because there's no necessity to get into anything of any real drastic direction. So this would be like your 10.1 network, And we're going to do really bad IP addressing here, so please do not follow this, all right? I always hate teaching classes because if you start naming things, people start going back in their labs and they just name everything the exact same way the instructor just wrote on the board. So there's like billion vol ones from the Novell days that were crafted in Novell. Everybody has DC1 and DC2 for their Active Directory domain controllers because that's what they saw in the book. All right. So anyway, we have 10.1 and 10.2, so separate subnets, if you will. These need to be advertised to the physical environment so that the physical environment knows that when a destination of something that it's receiving into the data center needs to essentially route through that edge to get into the NSX overlay. Now, the physical fabric doesn't know that it's going into an overlay or any of that. It doesn't care. It just looks at source and destination IP and just sends it on its merry way based upon standard routing metrics. So we're not doing anything of any disguised nature. Everything is the same as you would normally see within any type of VXLAN environment. The same idea that you still have to route to an endpoint for an IP value. And in order to get there, it needs to be advertised. So in our T0, in our edge, when we get a little bit later into it, it's going to advertise those networks into physical fabric. The physical fabric is going to have an understanding of it, and normal route servicing will move that frame into the Geneve or our NSX virtualized environment. Let's just stick with that instead of the Geneve now. So our NSX virtualized environment. And what will happen on that edge node is it's going to actually take 2 hops. All right, assuming that the edge node is not operating in a segregated T0 and T1, because we could, and I'm not going to get into that. That's another heavy-ended discussion why you might want to separate your edge nodes, T0 and T1 functions on that node. There's reasons for it and use case necessity for it for some specific aspects, especially if you're using SRs and things like that. But in the overall environment, most people don't. Let's just put it that way. So it's assuming that edge node has both of those functions. Well, it's just going to immediately hop between the T0 and the T1. So it's just going to immediately do so. And the T1 is a distributed knowledge. So what did I tell you? The control plane is going to have an understanding of where the destination MAC to an IP value is going to be. So we still have to have that old time understanding of ARP and all that understanding. But first off, we've got to locate that destination virtual workload inside of that T1. Now, how did it get to the T1? Well, we use a 10x segment for this communication, all right? And it's one that we go ahead and we tell customers you can modify. I think in the old days, we didn't let you modify. The old days of NSXT, I should say. I don't think we let you modify it, but now I think we do. So that you can make an adjustment in case that 10x network is somehow going to disrupt some communication elsewhere. But remember, it's a transient network. So even if it's used somewhere else, it's unlikely to be of an issue because it's not a routed knowledge. It's not advertised. No one else knows about it. All right, so it's just the T0 knows to send it to a T1 on a sort of a static auto route, if you will. All right, so the T1 gets it and it needs to then figure out a way to get to the endpoints on that logical segment. Well, as I noted before, the edge nodes has a TEP as well. So your edge nodes also have a TEP. All right, and at that point then it's going to encapsulate it and send it to the destination TEP of where that destination virtual workload resides within your fabric, and it will learn it through the control plane information that has been dispersed. And if not, then there's a means of utilizing either a communication through Ethernet broadcast or some essentially a directed multicast, if you will, not technically a true multicast, but more or less a directed request into a set of TEPs so that it can learn where that endpoint resides. And then from there, of course, manage its eventual passage in through the fabric. But when it passes through that TEP, it's going to then come back through this fabric connection here. All right, because the assumption is these are your edges are going to be on a separate clusters. We'll get to, of course, that in a later one. So there's a lot of things kind of like where you got to spin the wheel and jump on the wheel to learn stuff. Well, just assume that your edge cluster is probably a segregated cluster where your workloads are in many cases. Doesn't have to be. In many cases it is. So that way then it'll encapsulate the frame and send it to the TEP that corresponds to where that destination virtual machine has been learned to exist. And when it does that, it's going to then route through a single leaf spine, leaf hop, just like your leaf spine is supposed to do in a very efficient manner, but then go right back to that same VLAN destination value of the TEP and encapsulate that into the physical host of the vSphere host. And when it sees that, it looks at the frame and says, hey, That's that Geneve stuff that I'm running on my environment. And it says, I know what that destination VNI is, because that's something we haven't brought up yet, that these all have a VNI value, all of these logical segments. All right. They have a VNI ID value. All right. So all of these do. And it's going to know that. So it's going to know that VNI value exists in my environment, and I have that destination virtual machine, and it's going to decapsulate the packet and dump it on the logical segment so that the virtual machine can pick it up just like normal Ethernet mechanics, because the VM has no concept, just like you wouldn't if he was attached to a physical, or well, it still would be a logical, I suppose, VLAN. It wouldn't have any clue, just as they're saying. It just sees something from an Ethernet communication on his logical segment with his Mac and picks it up right off the wire and says, great, that's for me. I'm good to go. All right. So that's our happy, merry-go-lucky, general to specific, if you will, communication through a packet going into the environment. And as you'll notice, the mechanics at the very end is essentially the same as any Ethernet environment. It's just our overlay operates in our manner, as well as an overlay would operate within the physical fabric.
That's exactly what I wanted to just hammer out. Was these aren't, so for people that might not be, that are watching, that might not be network administrators or be as well versed in the OSI model and things, these aren't brand new concepts. These are things that are known and used in networking. BGP, OSPF, static routes that are there, ARP, and how we do these things, MAC addresses, IP addresses. We're not reinventing the wheel, but we're doing it in a distributed manner that allows you to be very flexible with your network design and ever so increasing without having to make a lot of changes in your underlay.
Exactly. And Andrew, that's a key thing there. We're making it so that when you manage the smart network connectivity and smart secure network connectivity inside of the NSX transport environment, the NSX virtualized network connectivity, the only thing that's required is this single abstraction, as I've mentioned multiple times. So this physical fabric can be VLAN backed, the old pod-based way of doing the access layer, distribution, and core, or a collapsed core, but whatever it is, you have VLANs of it all get demarked at the distribution layer, and then you'd have your inter-VLAN routing to get to someplace within that pod world. Or you could be using an L3 leaf spine, so it's just a routed architecture, or you could be using an L3 with a VXLAN fabric design, which is what most people opt for today. I think most people skipped over the L3 routed cloths, although there were some advantages to it, there were some severe disadvantages to it. They opted for a VXLAN fabric. So you often get people who will say, well, I have an overlay on top of an overlay. Yes and no. From a pure technical, if you're going to get really, specific about it, that's a true statement. But we treat the entire physical fabric as an underlay in itself. So how it ever does endpoint resolution down here, we don't care, which means we are agnostic to it, which means you treat this world just like you would treat this world over here. So AWS, Azure. You treat us just like that. You don't care. You have your interaction and intersection of communication between the routed edges servicing and then that one VLAN construct through a tunneled system that provides that transport node connectivity. And then when you map out all of the services here, it's the same thing as going into a VPC over here and just saying, I need this guy to talk to this dude at the endpoint here, and we're done. That's it. You're done with it. Same thing here, because everything happens, as you already noted, Andrew, in an automated fashion. If we draft another segment, so if we were to place another segment here, probably purple's up the better one. Let's use, let's say, yellow. Okay. With an ink that writes. All right. All right. And then we would use yellow here. It's one thing on light boards, yellow and green don't ever look too distinct. So trust me, that was yellow, that's green. I'm not colorblind. All right. So the yellow up here operates as the same as we did before. You'd have another IP segment. So we could draw this here. 10.3. As you can see, I'm really good at collating 10.3, 10.1, 10.2. All right. And we have this IP. When you create this segment, there's a feature in NSX when you manage the creation of a new segment, it will automatically assume, unless you've told it otherwise, to dump it into the route protocol as a connected network, because you state that you want all of the distributed routed segments to be operated on as a connected segment into your routing protocol, BGP or OSPF. So it operates as a connected route or a connected segment the way these particular routing protocols would then perceive them to be advertised to the external world. So obviously there's some differences in the way OSPF would view that and the way it's advertised and the way BGP would, but nevertheless, they are still automatically aggregated and then advertised out, with you having the capability of explicitly deciding that you don't wish to do that. All right, and you can make it managed on a per intersection or per.
I think that's a very, very important point that you just put there. And it's a little breadcrumb for actually a future show is, look, we're not doing this willy-nilly. We have the ability to also do route maps. We have the ability to fine-tune the redistribution. And most likely in this situation, you would treat this as a stub network. You're using BGP or OSPF. You're sending out the routes that you are advertising. So 10.1, 10.2, and 10.3 that you have there. And, and then you have a default route for the stub network to be able to go out into the physical network, and it goes and lives its world. But you don't have to necessarily do that. If you want to put those mechanisms there of doing route maps, or you want to be a little bit more safe to make sure that a rogue or a network administrator that wasn't sure, or put an overlapping address in there or an overlapping range, you could stop that from coming out. I just want to show that there's flexibility there, that there's thought process, and these are yet again things that we've been doing in networking for a long time, and that capability is built into NSX.
Correct, and that's something that we would want to get into another version. So we'll have to decide how we'll go ahead and begin to chunk out where we're going to get into these deeper conversations as we move more into our network capability in NSX. But we have fairly decent discriminatory means of managing what is intersected with between the virtual segments within NSX. In other words, just because these exist does not necessarily imply that they have to be able to communicate. You could use NSX in itself for the virtualized networking to disallow it. You could use security group mapping so that you map all of these logical segments in an abstracted name that would basically say this segment can't talk to that segment. All right, so that way it's essentially security that's disallowing it. So in case there are the exceptions that you need it and you don't want to have the absolute zero, which the networking would disallow, you could use route maps as you stated. That's another way. So there's all kinds of ways to infuse a discriminatory managed connection if you wish, without having to resort to just one or as an end all be all sort of end all. Everybody must connect and everybody shouldn't connect. You can be very specific of what is permitted, and you could do it down to, of course, smaller network prefixes than the one I have here, so that you can be, of course, just the same proper usage of your network domain space, your IP domain space that you should use within your data center site, so that you could use proper summarization techniques to make things simpler to manage the advertisements to the outside. Because remember, what we want to try and do is craft the simplest world, because that's our key: simple operation, simple troubleshooting. So we would want to make certain that we can summarize these so they're very easily understood, so that your physical fabric administrators will know if it's got this as a destination, or is this as a source coming from here or to there. It knows that it exists up here because there's summary routes being advertised at that border location. On the border lease, those would probably be what you'd nickname the routed segment from the physical fabric. And that way, then it's very easy to discriminate what you don't wish to allow in. So you could use your IP ACLs, if you will, on your physical environment to make sure source and destination communication is proper. Just so treat us like treat this world like a service provider would. Service provider would create a lot of knots saying none of this stuff should ever be going in and out of this world, and all of this stuff can. And then you can leave it even down to even more specifics if there is protocols that are known to never ever transact from a destination or source in this world to that world. You can make those types of negates, and then obviously your permits for all the other traffic, and then use the firewall nature that you heard from Chris to manage discriminate communication on an east-west basis for all of your other workloads. That makes it, the physical fabric uses its IP ACLs so that it manages secure knowledge of what should be transacted on a communication flow basis on a pervasive, a very 10,000 foot high level, and use the more discriminatory nature of our east-west firewall that Chris talked about that would be present in NSX, and it can manage all communication from a single pane of glass.
So I think we have two other topics because we're running out of time here. I would say, like, I like to try to keep these things, within about an hour and 10 minutes for the viewing audience, so it doesn't take up too much of your day. But I think there's two topics that we could talk about, and I'm going to leave it up to you, Paul, because I think you have a very good grasp for this. Do we want to talk about transport zones and nodes, or do we want to talk about DRs and SRs? What do you feel like you want the viewing audience to learn about here?
I think transport zones and nodes, because that gets us at least to a little bit more of a discriminate nature. And then the next time what we're going to do is we're going to go into a very detailed discussion of what occurs at the DR and the distributed routing and the edge, so that we can then get into multi-site, so we can really extrapolate out, so that we can talk about how that occurs. All right. So let's talk about the transfer zone was okay then?
I love it. That's a great idea. So you know what? That leaves a breadcrumb for the viewing audience. The next one that we're going to have when Paul comes on the show is we're going to get way in depth with DRSR and tier 0, tier 1. But for now, we'll round it out with, transport nodes and transport zones. So take it away, Paul.
Okay, well, transport nodes are the nodes itself that you would specify that are going to run the NSX networking services. So remember, when you're setting up NSX for security, there's a subtle difference in a bifurcated setup that you could say, well, I just need the NSX environment to instill the distributed virtual port groups in a native fashion to vSphere, so I can go ahead and use VLAN-backed security. Or I'm going to do networking and security, or networking only. You would go the other route and you would specify, I need to craft my edges. So you make your edges, as I've told you before, and you specify how that'll go. There's a wizard that takes you through that too, so something to be aware of. All right. And then you start specifying the addition of your transport nodes. Well, here's the beauty of it. Again, we make it simple. You specify that you have a virtual machine manager, right? So you'd have your vCenter environment, you'd specify it, and it will then go in through an authenticated credential set allowance and allow them to look at the vSphere clusters, so that you can start picking the clusters that you wish to add as your transport nodes, right?
Makes a lot of sense. And also there's things that we have out there, like you can create transport node profiles that'll help out with easing, the deployment to many different hypervisors that you have. You can do it by cluster. There's a lot of different things. You can do sub-transport node profiles, a lot of different things that we can do there to help simplify the deployment.
Right. So what Andrew's mentioning is that when you specify the connectivity that you wish to craft inside of your vSphere infrastructure, and you got the cluster. So it's not just as simple as I pick the cluster and voila, everything operates. You have to tell that host how is it going to interact with its physical, and remember, VMware uses that incredibly crafty name of the VMNIC, okay, which is essentially also logically mapped to something called the DV uplink inside of the DV port group configuration of your VMNICs to the DV uplink values, right? So anyway, that physical NIC, if you will, so it needs to know how to map it logically to the physical, so that you have essentially a profile value, or excuse me, a profile abstraction that will help you manage it, so that you can create a profile or a series of different profiles of different values of what you would have a necessity to interact with on each of those hosts. So there's a series of different constructs in NSX, so that you can either use sort of a holistic way of aligning it to a series of hosts in several clusters, or maybe these cluster of hosts has 2 NICs, this cluster of hosts has 4 physical NICs, so PNICs, if you will, right? Well, then obviously the profiles are going to be distinctly different, because you might want to have on the 2 host or 2 NIC cluster, you might want to have them do east-west for everything. And so what's everything? See, that's something we got to get back to a little bit, more of the basics. You have vMotion, or excuse me, you have management, right? So that's going to be one VLAN value you have to have. And you really only have to have, really technically, one other one in order for the NSX networking to work. And that's technically just the TEP. So you really only have to have that. Now you also have IP storage, you also have vMotion, and why am I forgetting one?
It's okay. It's live.
So we got management, IP storage, vMotion, and there's still one. IP storage, vMotion, and I know I'm forgetting it. I don't know why I can't think of it at the moment. So I hate when you have these blanks in the middle of a presentation, but
no worries.
But nevertheless, you would have the four default VM kernel services that you would have VLAN-backed connectivity requirements for, and then of course you would add in the TEP. So that's going to give you your basic elements of connectivity. Actually, the TEP is the fourth one. I don't know why I'm thinking it is actually more. That's the fourth. The TEP is the fourth. So there you go. We actually had them all. We just didn't realize we had them all. So we'll leave that one go, and then you're going to edit this all out. So
yeah, it's okay.
Gonna make us all talk smart talk. All right. Anyway, the TEP was the fourth one. I know what it is. I was just doing a VCF discussion, and there's another one there that's for the VCF and the replication and how things operate on a managed connection with our cloud foundation stack. But nevertheless, you have the four basic services, and remember, the only real ones you need, and I was right about that from the beginning, and that is the management and the TEP. IP storage is if you're going to use the IP connectivity services of the vSphere host to allot storage to the virtual workloads. You could have fiber channels, so you wouldn't need the IP storage, for instance, right? All right, but you could be using the iSCSI, or you could be using NSF, or you could be using vSAN, which is then holistically entirely within vSphere and structured within it and managed within it, but on that IP storage NIC. And then you have two other VLANs that you will want to use. These will be specific, though, to the edge. So on your transport nodes, you need the four I've already mentioned. That's it. Now, it sounds simple, and you think, wow, that's great. I only need four VLANs. Well, yeah, realistically, maybe. Okay. Let's talk about the cons. The cons are, do I have every virtual workload is going to be lumped into my NSX world? Yes or no? Ideally, that we would like to see yes, because you want to operate as a true cloud model. So every workload will eventually get migrated or deployed within it. But you could still deploy virtual workloads on the same host that's running the NSX services with the transport capability in VLAN-backed connectivity. In fact, you may actually be trying to map all of your NSX on a Brownfield environment, instilling the NSX VIBs, that's our virtual or VMware installable bundles, on the host, and you do so in, and this is cool here, right, in a non-disruptive manner. Now, if you have to remove them, things of that nature, or maintenance mode, that will require a disruptive maintenance up and downing of the system. You go maintenance mode, shuttle the VMs over someplace else, that kind of nature. But instilling it initially, it's non-disruptively, so that's cool. You craft your extra TEP, because if it's in a Brownfield environment, you already have the other three if they're necessary. So management, storage, and the vMotion environment already exists. So you're just adding the TEP. And then your dozens to hundreds of other VLAN values will begin to get deprecated as you migrate the workloads into the NSX world. So your transport nodes can be built from a Brownfield or from a Greenfield. I can't tell you what's preferable, because it's only preferable depending upon your world and your necessity to move into it from a use case need and how you wish to get there. So it might be better for you to just go ahead and extract out a handful of hosts from all your clusters and just maybe commingle some virtual machines on it, so you don't have to buy new hosts, and then make those the green environment and start building a brand new NSX world to start from. And then as you migrate workloads over to the new world, you can go ahead and then retire hosts and then add them in. You might buy a handful of new hosts to start that all off, that whole Greenfield approach. All right. Or you might just have a necessity to just essentially retire hosts because you're at that time of up changing and essentially
hardware refreshes, all that good stuff. Yep.
Yes, refresh. There we go. See, there's again got that whole vocabulary lost there. So anyway, right. So a hardware refresh cycle, which would obviously essentially still be the incorporation of a Greenfield with brand new hosts, but nevertheless. That's why there's no way to say it's preferably to do a Greenfield or a Brownfield. It's preferably to do the way that matches the necessity of your world. That's the preferable manner, all right?
Definitely, yeah. We make it flexible so that you can choose whatever route that you want to be able to migrate your applications in. You touched upon, we can have security-only method that you're essentially using VLAN-backed transport zones. Oh, that's a key term, versus overlay transport zones, which are within fully the NSX fabric and using the networking capability. We have both ways of be able to do it. Ideally, in my viewpoint, I think that you want to go toward the benefits of having the networking and the security. You want to be able to utilize NSX fully. But there are ways that we have you be able to onboard by strictly using your VLANs and using the DFW functionality, and you can bring yourself up to building that new network fabric. You can slowly work with your network team, bring that over, and then all of a sudden start bringing those workloads over into the virtualized networking that we have in NSX.
Correct. And we have tools to do that with. We have one that's essentially one that you would get on a license basis. I can't recall which tiered licensing you get, but I think you get 2 out of the 3 different tiered licensing models where you get a tool called HCX. All right. And it used to have the HCX used to have an actual acronym name to it. We've since dropped that. Just call it HCX. And it's a means of doing an L2 extension. So you would take your VLAN and map it to a VNI, and you'd be able to drag and drop your virtual workloads just like a vMotion. So it's like a hyper vMotion, if you will. And then there's, of course, other ways of getting there in a non-disruptive manner or a disruptive manner, depending upon the nature of how quickly you want to do it and just get it over with, if that kind of thing. And disruption is not an issue. If non-disruption is an issue, we have ways to make that occur, as I've just noted. So that's your transport nodes. Your edge nodes, just to kind of finish that off then, would be your edge nodes that you would have your cluster. I want to segregate it from the rest of the workload environment and create an edge compute system so that when I deploy these virtual edge nodes, okay, these VMware edge nodes, they're essentially virtual machine appliance format, into that cluster of hosts, and on specific ones, I can then craft an edge node, or excuse me, an edge cluster, and then my edge nodes would then get deployed into that edge cluster if I so desire, or I can operate the edge transport nodes on the regular transport node. So I don't have to actually segregate the two. So I could have a very small environment of only a dozen hosts, and I don't want to create 2 separate clusters. I want to operate my workload management and edge on one set of clusters. So we got environments, customers that do that, and they'll go ahead and make the management, the workload, and the edge all operate on that single cluster of hosts. And then they use vSphere HA servicing to make certain that whenever workloads of the compute nature need to fail over, they would fail over to specific nodes so that they would have a residing amount of compute capacity and things of that nature. Or they would also use the whole should would kind of a thing of when they should fail over in HA itself, or where they need to reside when they're automatically deployed. They would be able to deploy the edge nodes on specific hosts in the cluster, because remember, they do have to have physical interaction with the physical fabric. So they have to obviously align to a specific upstream connection into your TORs, your physical switching for that adjacency communication of routing. So all of those things can be handled. We've kind of scratched the top level service of networking, I think, which kind of clears us, or excuse me, ends us all out and gets us through the high level discussion. We obviously need to hit the finer points of a lot of things in that discussion as we move through our talks in later sessions.
Yeah, I definitely think there's a lot of different areas we could talk about. We could get back into how, the Geneva encapsulation works, going from TEP to TEP, and actually drawing out on a board exactly what happens there. We can talk about, high availability and disaster recovery, and how to be able to best put your edges out in a cluster to make sure that you're built for success. If you have a host go down, that it doesn't affect your edge cluster in general, how many you should have, how many clusters you should do, all that stuff. Man, we got a lot of areas that we can go down, but I think that's it for today's show. So we're definitely going to have you back on, and we'll do another topic, a deep dive of some other thing. I'm thinking that DRSR is a really good subject that we're going to have to hit on next time. So we're going to put that on the calendar.
Yeah, I think so. I think we can then get into also a little bit more of a granular nature of just how that interaction control and data plane communicates across that plane, and then how the SRs operate. So in other words, if I have a service on the T1, how does that work in an architectural, in a proper manner, so I can architect a solution properly, because I might want to know exactly what host in the cluster that's on. So if it has to fail over because it's an active standby type of service that I would like to incorporate. And then it's within the site, and it's important to be aware of how that works. Your SRs, obviously, for your physical interaction, we kind of covered that lightly here, but we'll definitely hit that much stronger, so that we'll go through a much deeper, granular discussion of how that works. I think the best part of that next discussion will also mean that I'll be able to really get why I might want to create a separate cluster for my edge, because I am going to grow, or I don't need it because I'm going to go ahead and create these pockets of NSX servicing because I've got multiple environments where I wish to have NSX, because we do have customers that spread NSX connectivity across literally hundreds of locations because they have this distributed communication network because of the different types of the different type of service they offer, where they'll have hundreds, if not 1,000 plus locations, and they would like to have their workloads operated upon in that environment, and they need intelligent, secure servicing of the network connectivity. So NSX gets dumped and spread, and we'll see these pockets of 3 and 4 host clusters across the environment, if not the world, for these customers.
Totally. Well, you know what? I'll tell you what, Paul. You know, this has been a great discussion. So what I'm going to do is I'm going to put you off to the side. But don't go anywhere because I need to talk to you afterward. We got to plan all this stuff. But thank you, Paul, for being on here. I appreciate you so much for taking the time and the effort to be able to show everyone in the viewing audience and the people that are going to watch the recording up on Twitch what networking is and NSX and how it works. So thank you so much.
You're welcome, Dan. Andrew. Appreciate it. Thanks for the offer to take the time to be here with me. That'd be great.
Absolutely. All right, ladies and gentlemen, thank you so much for joining the Twitch stream. Like I said, we're going to have some more things coming up. We have a show potentially coming up next week, but also 2 weeks from now. We're going to have a very exciting customer that's going to come on and going to tell us a lot about what he does in his environment. So a real customer interaction of how they use NSX, how they brought it into their environment, how they operated, and how they've expanded upon it over the years to make it really work for their organization. So I think that's going to be a very interesting discussion. I'm going to make sure that I let everybody know when that's coming up. I believe it's going to be June 14th, but let me do the final confirmation. So thank you so much for tuning in. Have a great afternoon, evening, morning, wherever you were tuning in from, and we'll see you next time here on the VMware NetSec channel on Twitch.